Hello, my friends of Hadre Labs. My name is Montoya. Please welcome to this tutorial. In this tutorial, we are going to do a basic example of seawater intrusion with a BUY package in Model Muse. So we are going to simulate the whole seawater intrusion phenomena with Model Muse entirely without any other tool. Okay, so in order to start this tutorial, what we need is the latest version of Model Muse. So that is 5.2 that you can download from the Model Muse site. Just Google USGS Model Muse, download. Okay, and then we are going to start a new Modflow model. Just in order to improve your view, I'm going to increase the size of my icons. Okay, great. Okay, so start again Model Muse. Okay, here new Modflow model. Next. Meters and seconds. Yep, that will work. Okay, so we are going to work with three aquifer 1 and aquifer 2 and aquifer 3. Okay, so this case we are working with 20 rows, 20 columns, 10 rows. Okay, and of width of 100. Okay, 3 layers and that's it. Finish. Okay, first of all, what you are required to do. Okay, this is the model, very simple model. Okay, you are required to activate the BUY package. So you go to model, you go to flow package, you activate this. Well, the storage will be activated, well, we can activate, but it will be activated because we are going to run it in transient, and we type the BUY package. Okay, and they say the groundwater transport is required. Okay, because when you run the BUY package, it actually, the variable density flow requires that you have a solute that will affect the density of the model of water, and then there will be an adjustment to the recharge equation, I guess. Okay, so but it will require a transport model. Okay, on the boundary conditions we are going to work with just general head boundary, and then here we have the EMS, and the EMS has to be on the linear, has to be on it has to be on BixG stop. Okay, great. And on one, and then on groundwater transport, okay, we have a chem species that it has to be in ACL just to, okay, we have a chem species, then we will have advection, dispersion with the default values, sink and source, because actually we need a sink and source. And then in the, we don't have the mobile. In the mobile is the sodium chloride without decay and without sorption. And on the solver for the transport model, here on the solver for the transport model, on linear we are going to use BixGStab. Okay, great, great, okay, great, okay, and then we need to define a transport, um, we are going to go to the Modflow time, the time discretization. Okay, so the first one will be steady state. Uh, yeah, that might work. Okay. What is the intention is like you provide, for example, 50 years of um, of a period previous to the model because you need that the seawater intrusion actually takes place because actually it needs to find the equilibrium in between seawater and fresh water. Okay, yeah, we can work it with 0 to 50 years. So 50 years in seconds is this amount. Oops, 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 oops. Copy output to clipboard. Okay. And then here, well, let's see, another 50 years, but on transient. Great. That is great. And then here, just every 10 time steps in the first one. And no, just 5 time steps for each one. Okay, great. Great, great, great. What else do we need? We need, in this case, the elevation is going from is zero, but we need something more real. And what is the more real thing is that we need the sea water is going to be, the sea will be here, but it will be a slope, okay? And the slope will be from 0 from 10 to 0, and the groundwater table will go from 5 to 0. Okay, so first of all, uh, and then we are going to do a refinement as well. So let's see, first we are going to create a polygon. Okay, we create a polygon to define the grid. Why? Because if we do the refinement, this is the grid, and the grid will be of 100, so nothing will change here. Okay, yes. Okay, but here we are going to do another where the refinement here will be 20 with another color. Great. Okay. And then we need more refinement on the vertical axis as well. So let's see here on layer groups. Let's see that here we have 10 layers. How say 5 layers, 5 layers, and 5 layers, 5 layers, 5 layers, 5 layers. Great. We can have more. Okay, let's see. Let's take out the the exaggeration. Yeah, more exaggeration, maybe 5. Okay, I think that yeah, that might do the trick. Okay, what else do we need? Okay, we have to tweak a bit the elevation because it's actually flat, so we need it from 10 to 0 here, or to 0 somewhere here. And we go to object, we hide all objects, and then we create 2 lines. We can create 2 lines. First line here, and this will be elevation of 10. and then in this case the formula 0, and this will be for model top with 10. Okay, and this is 0 and set values by interpolation. Okay, set value of interpolation. Okay, the same will be here. Elevation of 0, change that of color. Zero, and this will be model top 0. Okay, however this will be set value of interpolation. Okay, rate 0 and data set 0. Okay, great. And then we go here to data, to the data sets, and then we have to define on model top the for example, we can say fitted surface apply. Oops. Yes. Okay. So okay, and then here we have the slope. Okay, but we have a problem here, and the problem is that for this cell, since this is still interpolated, you can have negative values. Okay, so for that you create another polygon in this zone. Okay, where the, let's see that from here is the C elevation of 0. We change that of color. Okay, and then we go from 0, set values by interpolation in closed cells. Here we don't interpolate, we just apply the elevation of 0. Okay, and let's see that the interpolation is a layer that is below. Let's see that or let's assume that the interpolation is a layer. Okay, but when you apply it, since this is a new object, the interpolation is below this new object. Okay, and with that we have an elevation of 0 on the sea. Okay, great. So here is it. Okay, okay, here we have created our, we have interpolated. And then what else we are going to do? We are going to create an object here that is the, okay, in this column, that will be GHB of head of 5 meters. Okay, at 5 meters. Mhm. Okay, and then here will be a general head that will go from the starts to the end, and it will have a 5 meter. Mhm. And the conductance will be 0.001, and the chemical will be 0. And this will be direct. Okay, and on these cells, okay, we are going to insert this the C. So okay, so best if I improve the zoom. Mhm. And this will be a C as as EHB of elevation of 0. Change that of color. It will be at elevation of 0. And here will be a general head that will go from the stars to the end and the 0. And the conductance will be direct as well. This will be 0.001. And in this case, it's kind of confusing because here I specify that the concentration is the C, 35 grams per 35 grams per liter. Okay. However, uh, mm, I have to state that as initial condition as well. And I don't know if I run this without initial condition, what it will do. Okay. I think that I have to do both. Okay, great. Yeah. Okay, great. So here we have the initial condition. Okay, and what else do we need? Mm, we need that here on required on MT3DS, the initial concentration of this will be 35. Okay, so if you see, it's kind of confusing. This, what is this value here in the constant head, and what is this value here on the initial concentration? Okay, let's see. I don't know. Yes. However, okay, and in order to improve, because we need the, let's say, we need to set up the an equilibrium of free water of seawater and fresh water. And so far in the model, okay, at the beginning of the model, you only have seawater here on the cells, uh, here on the cells of the boundary condition. Okay, but you don't have, I mean, the water has to come and to find its equilibrium from here to this part. Okay, and then to find this equilibrium of fresh water and seawater. Okay, but this is going to take some time. Okay, simulation time. So for that, what we are going to do is we are going to insert an initial condition of the seawater intrusion in the cross section. Okay, so here I just say 1, 2, somewhere here, object like this. Okay, and this will be an initial condition of seawater. Okay, and this will be from the lowest. Okay, let me, the y coordinate goes from 0 to minus 1000. Okay, so let's see, let's go back again to the let's go from 0. Okay, once again. Okay, from 0 to minus 1000. Okay, yeah, you can create objects on the cross section, and this is as well 35. Mhm. Okay, and what else? Let's see something about the on the data sets. On the initial head, it will be model top. On the porosity, well, mhm, everything will be confined. Yeah, the first two can be convertible, but let's see that everything is confined now. Okay, then later on you can turn the first two convertible. Okay, and then we do apply. We save our project. Okay, so this will be, and then you are going to receive basic example of seawater intrusion. Okay, let's see, let's create a basic example of seawater intrusion with Modflow MF6 and BUY and Model Muse. Okay, great. So let's say seawater intrusion. Okay, let's see, let's save and let's run and see what is here and if it has run correctly. Let's see, we have some warnings, nothing to worry about. And on the results, okay, this is for the flow model that is running great. And this is for the transport model. Okay, and it has finished. Okay, this is the seawater intrusion list. Have a look on the water balance. Yeah, the that water is coming from the general head and is going mostly to the general head and is almost in a steady state. Okay, and for the transport, and this is for the transport model. Mhm. Mm. Okay, let's see what went wrong here because actually, okay, first let's have a look on the results for flow. Okay, as a contour graph, as contours. Mhm. What we have expected. Okay, and now let's read the concentration. Okay, at all times. Well, at these times in order to mhm, come as color grid. Mhm, mhm. Hmm, hmm. That is interesting. Okay, so there is water at the beginning, okay, but somehow, wait, what is this? Somehow the fresh water is washing the, yeah, is washing the, okay, and why this might be happening? Okay, let's go back again to the boundary condition 0, 35, 0. Mhm. Let's put that on the first on the first three layers. Maybe it's too weak the boundary condition. Okay, so we are going to put that in the first 5 layers. Okay, from the model top aquifer one bottom for the general head data, delete model results, and then run it. Okay, let's see again. Okay, let's have a look on the latest one to see if this has been washed again. Again. Mm. Hmm. Yeah, yeah, yeah. I got it. I got it. I got it. Is the sink and source. Yeah, the problem is that the boundary condition is not maintaining the 35 liters, the 35 grams per centimeter. Ah, okay. Here in package and programs, we go to the by package. Okay. Yeah, that was a problem. Yeah, in the flow package, in the buy package, okay. So this is the reference model, okay. This is the concentration. So actually there is no concentration, but for an increase in the concentration means an increase in the density, okay. So that is why data slope is 0.7. That I was actually because like we say, in the other case, for it doesn't matter the increase in the concentration actually was not an increase in the density, and this might be the reason why it was washed. And why? Because if we say 35 grams per liter times 0.7, it will be times the difference density is the density of salt water, that is 1021. Okay, so that is so we type okay, I think we close. Okay, delete model results, then run again. So in the other case, it doesn't matter if we increase the concentration. Actually, there wasn't up any fix on the density. Okay, and also on flow. Okay, close that. Okay, and then we take out the the concentrations, and to see, I will just have a look if this has worked. Yes, that was. Okay, now now I will show all the results. Okay, so let's see with the, let's import that again, but at different times. Okay, let's color grid. Okay, okay, so to gray. So that was at the beginning. Well, this is at the 4 time step of this first stress period. Okay, then this is at the second time step, first time step of the second stress period. And it has reached equilibrium from that. Okay, so because actually we don't see that much difference. Maybe the difference was at the first stress, on the first, let's say 10 days. Okay, so but what we can conclude based on this exercise and based in these flow conditions is that the, what is the, okay, the seawater intrusion has, based on this flow, uh, based on this a gradient, based on these flow conditions, actually we don't expect that the seawater have intruded more than 40 meters in land. Okay, but this is under this is something under these flow conditions. Okay, so we have to still test, okay, what happens if we do pumping wells, okay, and then we have to see what happens if we have drains and then we have another we have a geospatial part. Okay, so this is just something that say that the groundwater, this is something that say how the buy package works, okay, and which are the main steps to implement it, okay, and then later on we are going to complex that more with more with more cases and more scenarios. Okay, thank you, and oops, and see you in another tutorial. Bye bye. Have a great day.